Hey guys, welcome back to another video. Thanks to all the people that are watching the videos, doing the assignments, and submitting them. Thanks again to all the people that met in the Google Hangout, and for the people that are sending emails and communicating, trying to get the understanding of what they're doing so that they complete the assignments. Last couple of videos, we've been talking about rational expressions. We've been talking about domain, range, multiplying, dividing, simplifying rational expressions. It's probably not a stretch of the imagination. The next thing we should probably talk about is solving some rational equations. We've solved some equations like this before, so this is not too much of a stretch. It'd be a good review, as well as some extra little tiny things. I will also show a second method, which I haven't shown the class before. I know, so I always show it at the end of the year for like an opportunity for students to see which method they like better, and then you'll be able to choose which method you like going forward. So that way, if you don't like solving them like we have been, you can solve them using the second method and kind of go from there. Today, the goal will be to do the first two examples in the notes. I'll show you two different ways to do them, and then you'll work on the puzzle. On the puzzle, you'll do the first 6 questions, and then the last two examples, example 3 and 4 here on the bottom, as well as the remaining 6 questions on the puzzle will be the assignment for the next time that we meet. So let's just get it going and see what happens. So what does it say here? It says to solve rational equations, as with fractions, to add or subtract rational expressions with like denominators, just add or subtract the numerators. If two rational expressions don't have a common denominator, use a FFOO, which is a fancy form of 1, to get a common denominator and to combine the expressions. So in this case, remember what we said, is if you have two fractions and you want to add or subtract them, they have to have the same denominator. So if they don't have the same denominator, you can use a FFOO, or a fancy form of 1, to get them to have the same denominator. So let's see some examples, and that way you can try some questions on your own and see how it goes. So how about for example number 1? Here we have x divided by 5 plus x plus 4 over 3 is all equal to 4. So on this page, I'll show you how to do things with finding common denominators in order to add or subtract fractions. So right off the bat for number 1, we can see x divided by 5 plus x plus 4 over 3. If I try to add these two, I wouldn't be able to do it right away because x over 5 has a denominator of 5 and x plus 4 has a denominator of 3. So in this case, I got to think to myself, what would be a good common denominator? So in this case, a good common denominator would be the least common multiple between 5 and 3. The least common multiple between 5 and 3 is 15. So I kind of know what I'm shooting out for. But for that, before I even start doing any work, I probably need to talk about the domain. So here I have a special note. Eliminate any solutions that are not in the domain of a rational expression and check the remaining solutions. So in this case, I'll start with domain. We know domain always starts with all real numbers. So then how about this one here? Remember, when it comes to rational expressions, when I'm talking about the domain, the thing that I'm worried about the most is dividing by 0. So is there any possible way that in number 1, I'd be able to divide by 0? Well, I look at the first term. In the first term, I noticed I'm dividing by 5. That 5 doesn't have a variable attached to it, so it's always going to be a 5. Dividing by 5 in math is not a problem. So in that case, there are no issues there. So I scoot over to the next term. The next term I have is x plus 4 divided by 3. Again, that 3 is constant. There's no variable on it. It's not going to change. So in that case, that means dividing by 3 is totally acceptable as long as I'm not dividing by 0. And then if I go to the other side, it's just 4 with no division going on. So the question is asked, is there any possible way that I can divide by 0 in number 1? Well, in this case, no. So the domain is going to be all real numbers, which means any x value that I plug in will be totally acceptable. There's no possible way to divide by 0. So let's jump in. If I want to add these two fractions together, we said we're looking for a common denominator to be 15. So what kind of a fancy form of 1 can I use in the first term to get that denominator to become 15? Well, I think to myself, how can I get a 5 to become a 15? Well, I can multiply it by 3. So FFOO for the first one would be 3 over 3, which I'll multiply by this first term, x over 5, plus, now I move on to my next term, which has a denominator of 3. How can I get that 3 to become a 15? Well, I can multiply it by 5 over 5. In this case, we have the quantity of x plus 4 all over 3 equals 4. And on this side, I'm not going to multiply by 4 by anything. So then a lot of times students have questions like, why don't you have to multiply the 4 by something? Didn't you multiply over here by something? And why did you multiply by two different things? Well, think about what these things are. What is 3 over 3? It's just a fancy form of 1. What is 5 over 5? It's just a fancy form of 1. So if I take this left-hand side and I multiply both terms by two different but equivalent versions of fancy forms of 1, then all I've done to the left-hand side is just multiply it by 1. So if I multiply the right-hand side by 1, would it change the right-hand side at all? Well, no. So in that case, if I'm multiplying by fancy forms of 1, I know it's not going to change any values because multiplying by 1 doesn't change value. It's just going to change the way that it looks because I'm multiplying by a fancy version of 1. So this is the equivalent of multiplying the left-hand side by 1. So multiplying the right-hand side by 1 will keep it as 4 as well. So I think to myself, well, how do I multiply fractions? I just multiply fractions straight across. So in this case, I can multiply straight across like this as well. Well, in this case, I'll have 3x over 15 plus, I'll distribute this 5 inside of here. 5 times x is 5x. 5 times 4 is 20. In the denominator, we have 15. All right, and this side I didn't multiply by anything. It just stayed as 4. Well, now I'll look on the left-hand side. Could I combine these fractions now? Well, yeah, they have the same denominator, so now I would be able to combine them. So what is a 3x plus 5x plus 20? Well, I can combine a 3x plus 5x. Those are like terms. 3x plus 5x is 8x plus 20. They're over the common denominator, which is 15, and this is all equal to 4. All right, now I'm trying to solve for x, so how can I get x by itself? Well, I see division by 15, so I can multiply by 15 to get rid of it. So I'll multiply this side by 15 as well. So now I have 8x plus 20 is equal to 60, right? 4 times 15. Get x by itself, so subtract 20. Here I have 8x equal to 40. Divide by 8. And final answer here looks like x equals 5. Now the last thing I should do is check to make sure that x equals 5 is in the domain. Make sure the answer is in domain. Since we said for number 1 the domain is all real numbers, that means there are no restrictions on what x can be. X equals 5 is a totally acceptable final answer. So final answer, x equals 5. All right, guys, so that would be how you do it by finding common denominators. I do also want to show you this second method, which I haven't shown you before, but I always show before the end of the year, so I'm showing it now. So that way, if you like this method, you can kind of use it going forward. So the second method that I haven't shown you is something called clearing the fraction. I know a lot of you guys have mixed opinions when it comes to fractions. So how can you clear the fraction or get rid of the fraction without having to worry about common denominators? So similar to what we just did, we start with the same problem. If you were going to start by clearing the fraction, you could say, well, what's the first fraction that I see? The first fraction that I can see is x divided by 5. So how can I get rid of this dividing by 5? Well, most people know that multiplying by 5 gets rid of dividing by 5. So what you can do is you can take 5 over 1 and you can multiply it by everything that you have on the left-hand side. But this is different than the other method because in the other method we'd multiply by a fancy form of 1. But here I'm not multiplying by a fancy form of 1, I'm multiplying by 5. So if I multiply the left-hand side of the equation by 5 over 1, then I have to do the same thing to the right side. It would say 5 over 1, and I'll multiply that by 4. We do know that 4 is the same thing as 4 over 1, so it would look something like this. Well, how did that help, Mr. Z? How did it clear the fraction? That's a great question. So now that I'm multiplying this left-hand side by 5, I'm going to distribute this 5 over 1 in here. So then what would this first term look like? Well, if I'm multiplying fractions, they multiply straight across. 5 times x is 5x. 1 times 5 is 5. I would have 5x divided by 5. But wouldn't then those 5s cancel each other out? Another nice thing that cancels out, well, here I'm multiplying by 5, here I'm dividing by 5. They would cancel each other out, and it would leave me with just x. You see, and I've already gotten rid of one of the fractions. It's now just x over 1. But now I have to take this 5 over 1 and distribute to the second part as well. If I'm multiplying straight across, this 5 has to get distributed into both of these parts. So 5 times x is a positive 5x. Positive 5 times 4, positive 20. And that's still over 3, because if I do 1 times 3, it still stays as 3, equals 5 over 1 times 4 over 1 is just 20 over 1. You see in this method for clearing the fraction has already gotten rid of one of the fractions. It already got rid of this. All right, so if we're going to continue by clearing the fraction, then I just go to the next fraction that I see and I try to get rid of it. So what's the next fraction I see? I see this, 5x plus 20 divided by 3. So I think to myself, how can I get rid of dividing by 3? So to not cloud up the work, I'll put it here. I can multiply by 3 over 1. So in this case, my x is the same thing as x over 1 if you like it that way, plus 5x plus 20 all over 3. So if I multiply the left-hand side by 3, I'll multiply the right-hand side by 3 as well. So I get something like this. All right, and if I distribute this into this left-hand side, 3 over 1 times x over 1 is just 3x. And then the cool thing, if I take 3 over 1 and multiply by the second term, multiplying by 3 and dividing by 3 are going to cancel out, and will leave me with just the numerator, 5x plus 20 equals 3 times 20 on this side, which is 60. All right, combine like terms on the left side, 3x plus 5x, 8x plus 20 is equal to 60. Subtract 20 on both sides. 8x equals 40. divide by 8, x equals 5. And that was the same answer we got doing the other method, but notice in this case I didn't have to find any common denominators in order to get them to clear out. So this method is called clearing the fraction. If you look at the work kind of side by side, maybe you'd argue that there's not too much of a difference in length of work, but if you have issues with finding common denominators, then this might be the harder of the two methods. If you like the idea of clearing a fraction, I mean, these two steps I probably could have written a lot shorter if I wanted to. I just wanted to make sure you could see kind of what I was doing. So yeah, once you get the hang of this clearing the fraction, it could actually go a lot faster for you. And you'll see once we get to questions like number 3 and 4, which we'll discuss the next times we meet, this idea of clearing the fraction will actually be a lot faster. And if you don't believe me, you'll see it soon. All right, so let's go to question 2. This is the only other question that we'll discuss today. And then you'll have some time to try some questions on your own. I'll show it both ways. How do you do it by finding a common denominator? And how would you do it with clearing the fraction? So first things first, let's talk about domain. So we'll start with all real numbers. Are there any x values that would cause me to divide by 0? So I think to myself, is there anything that I can plug in for x that would cause me to divide by 0? So what about here? 5 times x. Is there anything I can plug in that to cause me to divide by 0? Well, how about 0? If I did 5 times 0, that would be 0, and I would be dividing by 0. So I know that's a problem, so x cannot be equal to 0. But are there any other x values that would cause a problem there? Well, no, if I take any other positive or negative number and try to plug it in, 5 times that positive or negative number will turn into another positive or negative number, but that wouldn't cause me to divide by 0, so I'm not afraid of any other positive or negative number. Here I have 3 divided by 10. Dividing by 10 is not a problem in math. There's no way that this 10 can become a 0 because 10 is constant. There are no variables attached to it. So in that case, I'm not worried about anything there. How about x plus 2 over 4x? Is there anything for x that I plug in that would cause me to be concerned? Well, very similar to 5x, plugging in 0 would be a problem because 4 times 0 is 0, and that would cause me to divide by 0. But any other negative or positive number would be totally okay, so only 0 is a problem. So for that reason, we can say the domain is all real numbers, but x can't be 0 because if I plug in 0 into the first fraction or the last one, it would cause me to divide by 0. All right, so how would you do number 2? That's a good question. I have a little bit of a hint for this one. Notice there are fractions everywhere, and all of them have different denominators. So one little trick that I thought was really nice when you're trying to find common denominators is that there's lots of different fractions with lots of different denominators. Try to get all of the denominators to be the same. And then you can use a trick that we've seen before a few times. So notice here I have 5x, I have 10, and I have 4x. What is the least common multiple of 5x, 10, and 4x? Well, if I try to find the least common multiple of all of them, I think I would get to something like 100x. So how can I get all of these denominators to become 100x? If I could do that, then I could probably do some things with adding them and combining them. So I think to myself, okay, I have x minus 8 quantity over 5x. How can I get 5x to become 100x? So I can multiply it by 20. So if I wanted to, my FFOO for this one would be 20 over 20. Now plus, here I have 3 over 10. How can I get 10 to become 100x? Well, I can multiply by 10x over 10x. In that case, 10x times 10 is 100x equals, and this side I have the quantity of x plus 2 over 4x. How can I get a 4x to become 100x? Well, what times 4x was 100x is 25 over 25. So something like this. Again, what's the reason why we can do different things for fancy forms of 1? Because they're all just equivalent to 1. So if I would take this side and multiply it by an equivalent version of 1, if I take this term and multiply it by 1, take this term and multiply by 1, haven't I just multiplied everything by 1? We know everything or anything multiplied by 1 is just going to be itself. Even though it'll look different, it will still have the same value. So here we go. I'll take all these fractions and I'll multiply them straight across. I'll distribute this 20 inside this first set. So 20 times x is 20x. 20 times negative 8 is negative 160. And now it's all over 20 times 5x, which is 100x. All right, plus 10x times 3. This is 30x. All over 10x times 10, which is 100x, equals 25 gets distributed. 25 times x, 25x, 25 times 2, positive 50, all over 25 times 4x, which is 100x. You see that? Now all of them have the common denominator. So let's go to the left-hand side. If these two fractions have a common denominator, I can combine them. A 20x minus 160 plus 30x. Well, I combine 20x plus 30x. This is 50x minus 160 all over the common denominator, which is 100x, equals 25x plus 50 all over 100x. And now we've reached kind of a nice familiar place. I have two fractions that are equal and have the same denominator. What else has to be true about two fractions that are equal and have the same denominator? Well, their numerators also have to be equal. But if you don't like that, another way that you can think about it is, how can I get rid of dividing by 100x? I can multiply by 100x. That would cancel off with this here. I can multiply this side by 100x as well, and I'll see that that cancels as well, which leaves me with just 50x minus 160 equals 25x plus 50. So solve for x, subtract 25x from both sides. At the same instant, I can also maybe add this 160. I would get something like 25x is equal to 210. So then I can simplify that if I want by dividing both sides by 25. So then I get x equals, and now I'm looking for, if I was doing this by hand, things that they have in common in terms of GCF for 210 and 25. You could do things with 5. You could reduce them to the calculator. Lots of options. You would get something like 42 over 5. So that'll be my final answer. But then again, the last thing I need to do with this answer is to make sure that it's in the domain. So 42 over 5, I noticed that the domain was all real numbers, but x could not be 0, which means that 42 over 5 is perfectly acceptable to me in the domain. It's going to be a nice final answer. So just like that, that's how you would do number 2 by finding common denominators. My suggestion is if you have lots of fractions with different denominators, just try to get them to all have the same denominator, and then you can use this trick where two fractions that are equal and have the same denominator must have the same numerator. Alright guys, so let's show method 2, one more, just clearing the fraction with the second example, and that'll be it for today. And then on the puzzle, you're only responsible for the first 6 questions, and then we'll do the other 6 the next time that we meet once I show you the other examples. We'll kind of go step by step. Okay, so how about clearing the fraction? So very similar to number 1, the first step for clearing the fraction, find the first fraction that you have. The first fraction I can see on the left-hand side, because I always read it like I read a sentence from left to right. I see x minus 8 over 5x. So I see dividing by 5x. How can I get rid of dividing by 5x? I can multiply by 5x. So I do 5x over 1. I'll keep this quantity the same. I'll keep this quantity the same just to show you the steps. And then if I multiply this side by 5x over 1, I got to multiply the other side by 5x over 1. So the first step would look something like this. But why is it a nice first step? Because in the first one, if I'm distributing this 5x over 1, 5x over 1 times x minus 8 over 5x, multiplying by 5x, and dividing by 5x would cancel each other out, which leaves me with just the quantity of x minus 8. You see I've already got rid of the first fraction. Now I'll take 5x over 1, I'll distribute into the second one. 5x over 1 times 3x over 10 would be 15x over 10 equals, I'll multiply this guy by distributing inside there, 5x times x, 5x squared, 5x times 2, 10x, all over 1 times 4x, because it goes straight across, is just 4x. You see, clearing the fraction, I've already gotten rid of one of the fractions. Now I'll move on. The next fraction I can see is this guy. So what would you multiply by? Well, you can multiply both sides by 10. So I'll multiply by 10 over 1. Why am I doing that? Because I'm seeing divided by 10. What's the opposite of dividing by 10? Multiplying by 10. But if I multiply that side by 10, I have to multiply this side by 10 as well, which is the same thing as 10 over 1. So in goes 10. I'll multiply it by everything. 10 times x, 10x. 10 times negative 8, negative 80. 10 times this 15x over 10. Well, multiplying by 10 and dividing by 10 cancel each other out. So I'm left with just plus 15x equals, this 10 got to get multiplied by everything at the top there. 5x squared times 10 is 50x squared, plus 10x times 10, which is 100x. On the bottom, 4x times 1 is just 4x. You see that? Combine like terms on the left side, 10x plus 15x, 25x minus 80 is equal to the same thing we have here, 50x squared plus 100x over 4x. How can I get rid of dividing by 4x? I can multiply by 4x on this side, so I'll do the same thing over here. distribute the 4x inside. So here I have 100 x squared minus 320 x equals 50 x squared plus 100x. Okay, subtract 50x squared from both sides. At the same time, if you want, you can also subtract this 100x. So I'm left with 50x squared minus 420x is equal to 0. You can pull out a GCF. The GCF of these two terms is a 10x. Inside here, you're left with a 5x minus 42 equal to 0. Well, if two things multiply to 0, then either the first one, 10x, has to be equal to 0, or the second one, 5x minus 42, equal to 0. If I divide both sides by 10, x equals 0. If I add 42 and divide by 5, x equals 42 over 5. So then notice 42 over 5 is the same thing that we got on the other sheet. So we did get that same exact answer doing it the other method. But how about this 0? What about x equals 0? Could it be a solution, x equals 0, for this equation? In this case, it can't be, because if you go back to the conversation that you had about domain, remember we said the domain was all real numbers, except x could not be equal to 0. So then if I get x equals 0 as a possible solution for this equation, then I know that it has to be extraneous. It was not in the domain. So then you can cross it out and then say, final answer, x equals 42 over 5. So even if you are doing the clearing the fraction method, then just make sure to also consider the domain in the beginning. You still have to do this step by first saying, what are some x values that I can't have that would cause me to divide by 0, and I want to make sure to stay away from those. Okay guys, so there are two different methods for solving these kinds of things. In terms of today's assignment, I don't want you to do the entire puzzle. I think there are some things I still need to talk about with example 3 and 4. So notice example 3 and 4 kind of takes things up a little bit. So let's just start kind of with these first two and see how it goes. And that way I can get some feedback from you guys and see where it goes. So how about for today? Let's do the first 6. So you'll be responsible for these. I think those are very similar to ones that I did in the note sheet there. So use those kind of as a starting point. And we'll see what happens. And then the next two examples I'll give you the next time that we meet. And then we can do these things down here. All right, guys. So if you can do questions 1 through 6. And then you have answers on this side. It does say if the answer has a box, then shade in the box instead of writing a letter. So find the answer, match it up, write the letter on the bottom. If you could do it on a separate sheet of paper and kind of go from there. If you do want to try the bottom 6, that's totally fine by me. You can ask me questions, shoot me email, whatever you need to do. I'm more than willing to help. All right, guys. So thanks for watching the video. Let me know if you have any questions. Good luck on the assignments. And I'll see you in the next one. Have a good day. Bye-bye.